Good afternoon, everyone. Thank you for the opportunity to present one of our works, which is titled Design and Construction of a Solar Dryer with Hybridization of Solar Technologies for Drying Fish. Well, first of all, I will start commenting that food drying is a method of food preservation in which the growth of bacteria, fungi, or germs is inhibited by removing water through evaporation. This process requires high energy consumption because need to evaporate the water contained in the products and the low efficiency of current industry dryers. It could have great potential, reducing conventional energy consumption by up to 80% of the total energy uses in said processes. And finally, Mexico has an important solar resources, which make the development of solar drying for dehydrating food products attractive, which would benefit the food sector. Mexico has great potential for the development of fishing, its extensive coastline of 11,000 kilometers. Besides, Mexico contributes worldwide with 12% of the diversity and more than 12,000 endemic species. The fishing sector is essential for the generation of food and its contribution to the national economy. Sea products are accessible food to satisfy national demand and promote a greater supply to national and international markets. In Mexico, 54% of the fish and shellfish caught are lost for various reasons, such as absolute distribution process, lack of infrastructure in the supply chain, lack of appropriate vehicles, poor marketing practices, lack of training of personnel, of conservation and product handling. To experiment, the fish of Chakchi, Armado, and Box species were selected because these species are native to the state of Campeche, and they are sold at a very low cost. Besides, it was experimented on without a lot of fish, and well, this study presents this last case, reporting the temperatures reached in the solar dryer. The solar dryer for sea products has three main sections. The first is the chamber for drying sea products, which is made up of two containers in the form of rectangular ducts. In the state of grids, with a capacity of 4 kilograms of product for each grid, for 40 kilograms of fresh product. This section is thermally insulated and has two doors with hermetic sealing and safety hinges. The second hot air distribution section comprises a rectangular duct with an area with 6 aluminum and glass shutters that distribute the flow of hot air that will later pass into the drying section. And as well as the first one, this section is thermally insulated and has a door with an hermetic seal and safety hinges. In the third section, for directing the flow of hot air, has a rectangular duct which inside has two gate valves that have the function of entering the hot air into the drying section through two possible ways. The first is the entering of hot air produced by the bank of solar collectors for air heating, and the second one, entering the hot air produced by the bank of solar collector of water heating and the water air heat exchanger. And this section is thermally insulated and has two doors with hermetic seal and safety hinges as well. These are the three auxiliary subsystems of the solar dryer. First of all, we have the solar air heating system. It is made up of 6 solar air heating collectors, and they are distributed into parallel rows, with 3 collectors in series for each of the rows. The solar collectors are coupled and interconnected to the dehydrator through conical chambers and circular ducts of 20-gauge galvanized steel. The second one is a photovoltaic solar power generation system. And finally, the solar water heating system. It is made up of 6 solar water heating collectors, and the arrangement of the collector bank is distributed in 2 rows in parallel, with 3 collectors in series for each one of the rows. For the solar dryer to operate continuously, a solar air heating system is required that directly supplies the hot air flow to the dryer when there is sufficient solar insolation. During periods when there is not enough solar radiation or at night, a solar water heating system with thermal energy storage will be used. With this system and a water-air heat exchanger, it would be possible to supply the energy hot air indirectly for drying operation. Heat exchanger made of copper tubes and aluminum fins with a thermal capacity of 42 kilowatts, an effective heat transfer area of 1.5 square meters, and an actual airflow extractor fan, with a circular cage rotor coupled to a three-phase electric motor of 1 HP capacity. The drying process of food products demands a significant amount of energy during the overall dehydration process. For this reason, renewable energy technologies are used in this dryer. For the solar dryer for fishery products, a solar photovoltaic system was designed and installed to generate the electrical energy required to drive the extractor fan of the solar dryer. The SFB comprised 3 solar panels. Each panel has a catchment area of 2.61 square meters and 454 watts of electrical power for 7.83 square meters of the catchment area with 1,362 watts. As you can see in these images, in the top we have the chimney. Then we have the control panel, and in the right we have the drying tunnel. In the back you can see the solar water heating system. And then we have different views of the tunnel type indirect solar dryer. For example, in the left we have the drying chamber, and in the right we have the solar air heating system and the photovoltaic solar power generation system. The thermal evaluation presented in this work used the solar thermal system for direct air heating, and it was carried out by circulating air at room temperatures through the arrangement of solar air collectors, using the fan extractor to enter the hot air flows to the solar dryer directly. And well, some of the results are presented in the above table, where you can see the, for example, inverter frequency at 15, 30, 45, and 60 Hz. Measure variables like inlet air temperature of the solar dryer, air temperature at the outlet of the solar dryer, and air velocity. Well, we have a little diagram of the solar dryer coupled with the solar thermal air heating system directly. As you can see, we have row 1 and row 2. This has 3 solar air heaters that will pass to valve 1 and then to valve 2. Then we will have the solar dryer and finally the chimney. The solar dryer for sea products with all its components was installed in the Faculty of Engineering of the Autonomous University of Campeche. The solar thermal system for air heating was installed and coupled to the solar dryer to operate the dryer with a hot air supply directly and carry out its evaluation when working in this way. The photovoltaic solar system (SFP) was installed and coupled to the solar dryer, which allows for supplying the demand of electrical energy that the solar dryer demands. With this photovoltaic system, the dryer can be operated continuously on sunny days, cloudy days, or at night with the battery's energy storage. When operating the solar dryer with the solar air heating system operation mode 2, to directly heat and enter the air into the dryer, average temperatures were obtained inside the drying chamber from 54.5 Celsius degree to 61.5 Celsius degree, with average airspeed of 2.4 meters per second and 10 meters per second, respectively. Acceptable as average temperature of 55 Celsius degrees are required for drying fishery products with average flow rates of 2.5 meters per second inside the dryer.